So let's look at the Develop Hub, which is where you'll go to pull up scripts and notebooks that you've already created, and you'll save and you'll maybe share things amongst your team. So now I'm in the Develop Hub. Once in the Develop Hub, I have my SQL scripts and my notebooks where my Spark code lives, and I can work with and develop new resources here as well as change existing resources. Without going too deep into how this all works, because I really think those are better for deeper dive sessions, just a quick glimpse that I can pull open a serverless SQL script. This is my setup script where I'm going to first just kind of test out the data with open row set, and that's a valid way to query data with serverless SQL. You'll need to make sure there's credentials if required for your location, and then set a format for what you're querying. The other way, though, is actually create external tables so that they'll show in the data hub, so they'll be there for other users to access, and that involves creating file formats if you're first time using this format within your environment, creating data sources. Sometimes you'll embed some credentials along the way. In this case, I think I'm using managed identity to pass through the credentials. And then you can create external tables. And so the syntax is going to be not too different from Hive QL and how you create tables there, or Spark SQL creating external tables, but a little bit different than SQL Server. It's kind of somewhere in between Hive QL and SQL Server in my experience. But it's pretty easy to get used to. You won't really have a huge learning curve to get started with this once you get the basics of creating those databases and formats. Once your tables are set up, other users can come in and run pretty standard T-SQL in order to get the results that they need. Some of the functions may be different, but a lot of this is going to be the same functionalities you'd find in Azure SQL. And so it'll be really comfortable for users to work with. Depending on what you're doing, just you're querying a file system. So if you get the partitioning and the storage format well, then the results will be pretty quick for exploratory analysis. If you're going to be running reports live against this, a lot of times it's going to be slower than your users are up for, and you'll need to do reporting extracts or use dedicated SQL or Azure SQL for serving up live reports to something like Power BI or maybe even Tableau. But you can get quite a bit of mileage on serverless SQL. And the way it works, if you're new to it, is that you're paying for what you process, what data you query in order to get the results. And so it ends up being, I think right now it's $5 per terabyte processed. As you run queries, you can keep an eye on how much data is being processed in order to get you those results, and try to manage your costs that way. But for uh, just a infrequent use exploratory analysis, it's usually a pretty cost effective way to get started with data within your data lake and keep people in T-SQL that they're comfortable with if they've been working with SQL Server and Azure SQL for a while. So while we're in the SQL script section, let's take a look at a few dedicated SQL scripts. And so we'll start with the basic. It's just T-SQL. We are thinking about how we're doing our where clauses and group bys to try and make sure we're using good distribution techniques on our fact tables, but we're running a query here. And in this case, it's not a highly optimized table or highly optimized query, and it's the very smallest dedicated SQL pool I can find. Now, I've already run this thing, so there's probably some caching going on, but I get those results back in fairly quick time, but nothing blazing, nothing too special there. But let's just take one more look that I can also run a query that has having clause, has a little more detail in it. And in this case, I don't think it's going to literally bring back all the results to the portal, which doesn't make much sense to do anyway. But if I was exporting elsewhere, it should process through this data and export that data to where I'm going, such as a Power BI extract or something like that. So nothing too crazy to show there, right? That didn't show off any capabilities. I'm not doing some amazing performance tests for you. So here's a more important thing to show about dedicated SQL, even though we'll still keep it pretty high level here, is that when we create our table, we have a lot of the same syntax. It looks very similar, but ultimately I need to decide some things about how I do indexing on the table. Clustered column store index is a good way to get performance for a lot of tables, but it's going to take some overhead and something you'll want to make sure you understand, versus you can do more traditional type of indexing on it. And then distribution is important. This is more of a fact table. There's quite a few records that are going to be queried and filtered on a lot. And so my main place I'm going to filter is on the pickup date. And I think it's going to be fairly well, the data will be fairly well distributed over pickup date. So I'm going to actually distribute the data on pickup date. What that means is we have 60 distributions, and it's going to split the data up based on pickup date. It'll do a hash on top of that to try to avoid data skew affecting it too much. And that's how it'll store it. And that'll probably work well for my larger fact tables to give me better performance. What you don't want to do is have your largest tables replicated. Replicated is good for small dimension tables that you're going to do joins to because from your larger tables, because that will make the data available on all 60 distributions, right? So it takes a little time to get the data pushed out to all those distributions. But if you're going to be querying it a lot from your larger tables, you can get performance benefits by doing that. With the larger tables, you need to figure out how do you want to distribute it, and hashing is one common way to do that. So at the bottom, I have a copy into statement, which will be a fast way to load from data lake storage into that dedicated SQL table. And it's a pretty easy command to look up the information on. Parquet format's pretty simple. You don't have to add a lot of information about it. If you're going to do this copy into with CSV, check out the different options. Those could really make a difference on what you get. So just keep that in mind. So dedicated SQL really is that massive parallel processing. It comes at a higher cost. It takes a little more thinking about how we distribute the data and things like that, which you really should be putting into the layer that you're going to query live on. For ad hoc analytics, exploratory analysis against your data lake, serverless SQL is very capable. It'll give you performance that works for ad hoc exploratory things. And Synapse Spark SQL is also an option for querying. It's going to be a slower startup time. You're talking like 3 minutes or so to spin up those pools to work with Synapse Spark SQL, whereas serverless SQL is really quick, and dedicated SQL, if the cluster's on, is very quick to get you those results, of course. So let's move on to our Spark notebooks now. Now, to get some of that data loaded up into the Lake database in the first place, Synapse Spark is the tool I use for that. If I go to notebooks, that's where a lot of my PySpark code will live. PySpark is the default, by the way, which means Python with the Spark APIs. You also have Scala or .NET, which is C#, or Spark SQL, which is just using SQL syntax. It's a pretty standard syntax with some special functions and things like that. Not the full T-SQL that serverless SQL has, though. And so with these different combinations of things, you can process a lot of data. You can ingest from a lot of sources if you choose to. It's very easy to work with the data lake storage here. And it's really not that crazy to get connected to other resources as long as you can get the networking pieces configured, which does take a little extra effort in a secured environment. Now, I won't go into the syntax here. I have other videos on Spark SQL and PySpark and .NET, so you can go find those on my YouTube channel if you choose to go a little deeper on that. Thanks. See you next time.